Good afternoon and welcome. Today, I will present our solution to automate your AQA tests on your CyberKnife devices. As always, we use our CK imager, our high-energy portable imager, to carry out these tests and avoid the use of radiographic films. Along with our CK imager, you will need the following hardware materials: the cover for protection and to stop scattered radiation, our dummy cover, our slab cube plate to maintain the cube provided by Accuray for the AQA test. This plate is used with this accessory, the CK tilt, which tilts the imager to 35 degrees. Here you can see the ball cube phantom installed on the CT scanner, with the dummy cover, which stimulates the exact geometry of our portable imager, installed on the tilt accessory. On the dummy cover, you have the slab cube plate, which maintains the ball cube phantom equipped with its acrylic ball. Here is the same installation on the CyberKnife. The only difference is the real cover with the CK imager inside and the ball cube phantom equipped with its metal ball. Here you can see the image we obtained. In a single image, we can see the anterior and the lateral beams. Our two software modules dedicated for your AQA tests are the CK Pilot module used to manage acquisition with the CK imager, and our CK-GEOM module to automate the AQA test that we will cover during the demo. Okay, let us start the demo and carry out the AQA test. I have already launched QUALIMAGIQ. Please refer to our full video linked below on how to connect to this platform. Once connected, you will go to the import menu and select the corresponding option, which will show you how we drive acquisition with our portable high-energy imager. When you arrive at this screen, you must first test the connection with the imager already physically connected. Test the connection by pinging the imager's IP address to test that QUALIMAGIQ can communicate with the imager via the network. The next action is to choose on the right a protocol already declared in QUALIMAGIQ. A protocol is a list of tests, and inside each test, a list of images that we have to acquire. Each image in this list is described by a list of tags. We can see under the GEOM module tag the very common AQA test with the iris collimator, normally done with films, but now replaced by our CK imager. The name of the exam is by default the name of the protocol, but if you wish, you can modify it. The next step is to complete the acquisition. I will launch the acquisition and I will explain to you as I go. As you can see, to acquire this image, we need to accumulate 800 frames. Indeed, on this image, we want to see the anterior beam and the lateral beam, but we do not want to interrupt the acquisition when the robot turns between the two beams. The sequence is therefore as follows. You start the acquisition with 800 frames with an integration time of 100 milliseconds. You start the treatment plan including the two beams. The first beam is delivered, the robot goes to the second node, and the second beam is delivered. Finally, the acquisition stops after 80 seconds in total. This means that we will have many frames without signal, but the system will automatically delete them to have an image which only accumulates images with signal, that is to say, with MUs. In the next step, QUALIMAGIQ displays a curve where all the frames with signal are in green and the frames without signal are in red. Given that QUALIMAGIQ knows from the image tags declared in the protocol the quantity of MUs programmed for each beam, the dose rate of the machine, and the integration time of each frame, the software calculates the number of frames expected. The expected number of frames with signal is 36, and we can see that 36 frames with signal are detected. This check of number of frames confirms that the image has integrated all of the MUs of the two beams. This check is crucial when you want to measure output factors, and/or replace your diode measurement with our imager to perform MU constancy checks. QUALIMAGIQ also detects the number of beams acquired and compares it with the number of images declared in the protocol. For the AQA test, we expect 2 beams and the system detects 2 of them. Everything is now green, and we can see that there are only 76 frames left with signal, which will accumulate to produce the image. We therefore acquire 800 frames, but only 76 were ultimately used. The resulting image is the following, in which we can see the 2 beams of the AQA test. We add the image to the exam, which is now complete. When you leave this module, the exams acquired and encoded in DICOM format are imported into QUALIMAGIQ to be automatically analyzed. So we find in the QUALIMAGIQ welcome screen the AQA test and the exam including all iris sizes. All you have to do now is select one and click on the Analyze button, and the system will automatically analyze it and display the analysis report. This report and the associated PDF reports are fully configurable by clicking on the Set Report button. Thus, we can see that the user has decided to highlight certain results, which displays them in blue and bold in the reports. Most of the time, these highlighted results correspond to mandatory results under your national regulations, and QUALIMAGIQ automatically produces 6 PDF analysis reports, 3 of which only contains these highlighted results. Now, you can comment on this analysis and accept it so that QUALIMAGIQ produces 6 PDF reports. But first, I will show you the details of the analysis by clicking on the step-by-step button. In this mode, you can see the analysis in detail, and with the Complete Settings button, you can access the analysis settings. In this AQA test, the imager being tilted, the image of the conical beams and the radio opaque ball becomes ellipsis. The first step of the analysis consists of detecting the contours of the ball and the beam targeting it, performing an elliptical regression on the points which define each contour to deduce the center of the beam and the center of the ball. Trigonometric calculations are then carried out to determine in the 3 directions of space the offset between the point of intersection of the 2 beams and the center of the radio opaque ball. QUALIMAGIQ also provides this distance offset. Here, the results are excellent, so we can find 0.2 millimeters. But of course, access to the step-by-step mode is not part of the routine workflow, so I am going to come back to this routine workflow by showing you each of its steps. Remember, I am on the welcome screen, and after I have acquired and imported the images of my beams to analyze, I select an exam and I click on Analyze to start the analysis. The analysis report is displayed. I can comment on this quality control, and I accept the analysis by clicking on this button in order to produce the PDF analysis report. As not all users are authorized to produce these reports, QUALIMAGIQ asks me to enter my password to verify my rights and record my name in the PDF analysis reports. QUALIMAGIQ automatically opens one PDF report, the shortest, which you can print if you wish. Since it is a list of results, it's quite economical in ink. In this first PDF report, you can see your name, the logo of your clinic, your comment, the date of acquisition, the date you accepted the analysis, and the list of results with their respective tolerance intervals. To see the 5 other PDF reports, simply click on View, then go to the protocol that interests you and select the type of PDF you wish to consult. The complete PDF with all the details of the analysis coming from the step-by-step mode, no one prints this because it consumes a lot of ink. However, it remains available in the View function. If you want to see the short PDF report containing only the highlighted parameters displayed in blue and bold, you will select these 2 options. In total, QUALIMAGIQ produces 6 different PDF reports for the same analysis: the complete one, the short one, with failed results, highlighted or not. Okay, we have reached the end of this demo on how to carry out the AQA test using our high-energy portable imager along with its accessories. We also covered the use of our CK Pilot and CK-GEOM modules to automate this test on your Cyberknife devices. However, before you leave, I would briefly like to add that our QUALIMAGIQ solution automates many more tests. Here is a quick summary of all the tests that our filmless solution offers. We automate the AQA tests and other geometric tests with cones, iris, and MLC, output factors with these 3 collimation systems, the garden fence and picket fence tests for the MLC. We test field size for cones, iris, and MLC, circularity, penumbra, symmetry, flatness for cones and iris. We carry out tests of MUs with our CK imager to evaluate their constancy, repeatability, and linearity. Soon, we will complete these tests on the MUs by testing the beam energy and the geometric tests by testing the laser point. We also automate the isocrystal test. And for the imaging system, we analyze the spatial resolution and contrast tests carried out with the Tor Phantom, the geometric distortions carried out with our Phantom and its accessories, the noise and the homogeneity of the signal, finally, depth dose curves and profiles from a water tank, matrix, or profiler. For more details on our portal imager and/or all the modules to automate your quality controls on your Cyberknife device, please watch our full video on our website. I will link the video below. You can also contact us for any commercial or technical questions. I thank you for your interest in our solution and for taking the time to follow this presentation.